Good morning, dear students. I'm Dr.T.Anuprathibha, Associate Professor from Department of Information Technology, V.S.B Engineering College, Karur. And in today's session, we are going to see about the conventional and public key cryptography, the second topic in Unit 1. I'll share my screen and then we will proceed. So in the first unit, we are going to see about the conventional and public key cryptography. So we will start exploring about this particular topics. So what is cryptography? It is an art and science of secure communication by transforming readable data, that is plain text, which is an intelligible message, into an unreadable form, which is an unintelligible message, otherwise called as ciphertext. So it forms the backbone of digital security, protecting sensitive information as it travels across networks. And this technology, it ensures three critical security principles. As already we have seen in the first session, it is a CIA triad, that is confidentiality, integrity, and authenticity. So confidentiality, it is meant for keeping the data private, integrity for preventing the unauthorized modifications, and authenticity for verifying the sender identity. So this conventional cryptography is nothing but the symmetric key cryptography, in which we will be using the single secret key. It uses one shared secret key for both encryption and decryption operations. So here we are sharing the key in a secure manner. So sender and receiver must exchange the secret key securely. And then it is very fast and efficient. And it is ideal for encrypting large volumes of data quickly with minimal computation overhead. And then conventional cryptography, it exists in scenarios where parties have already established a secure key exchange. So common algorithms include advanced encryption standard and data encryption standard, which is otherwise called as AES and DES, with AES being the modern gold standard for symmetric encryption across industries. And now we are going to see about the conventional encryption process in detail. So here, two persons, Alice and Bob, is going to share the particular secret message. So first, Alice will be encrypting the message using a single key. This particular single key is a secret key which is shared among Alice and Bob. The other persons, the third persons, are unaware of it. So here, the allies will be encrypting the plain text. Plain text is the actual message what we want to convey to the other person. So that is what is said to be encrypted, and it is converted into the ciphertext. And then again, this has happened with the help of the encryption algorithm. And then finally, the ciphertext is created and it is transmitted through insecure channels safely. So here, in the decryption phase, Bob will decrypt the ciphertext by using the same secret key value, and with the decryption algorithm, the final actual message, the plain text will be decrypted. Plain text will be obtained from the decryption, and then the exchange process is over. So what are the challenges? If you see, the first one is key distribution problem. Second one is single point of failure. Third one is limited authentication. So here in key distribution problem, securely sharing the secret key over insecure channels. It is a challenging one, in which it leads to security challenge. So how do two parties exchange a key without eavesdroppers intercepting it? So that is the question that arises here. And next thing is single point of failure. If the secret key is compromised through theft, interception, or social engineering, all encrypted communications becomes vulnerable. So there's no backup security layer here. And third one is limited authentication, in which the conventional cryptography, it doesn't inherently provide authentication of non-repudiation. So you cannot definitely prove who encrypted a message or prevent them from denying it later. And next concept is we are going to see about the public key cryptography, which is revolutionized secure communication by introducing a mathematically linked pair of keys. So here we are going to use a public key and a private key, in which the public key is freely distributed and a private key is kept secret. So the first step it happens is key pair generation. Each user generates two keys. One is public key, another one is private key. And second one is public distribution. The public key is shared openly. Private key remains confidential. And next thing is secure encryption. Anyone can encrypt with public key. Only the private key holder can decrypt. So this eliminates the key distribution problem entirely. So common algorithms like RSA and elliptic curve cryptography and LGAMAL are based on this particular type. And now we are going to see about the public key encryption process, in which first scenario is already we have seen is key pair generation. So first the Bob generates the key and then it publishes the public key. So then here the Bob will be encrypting the plain text using the public key of allies. Okay. And then again, this particular message, the plain text which is converted into ciphertext using the encryption algorithm will be decrypted using the private key, which is only known to the allies. So first thing is Bob will be generating both the keys, public key and private key. Public key will be shared publicly, whereas the private key, it is known only to the Bob and allies. So here the Bob will be encrypting the plain text by using the public key of allies, and then it will create the ciphertext using the algorithm, encryption algorithm. And this particular ciphertext is said to be decrypted using the private key of allies, and then he will decrypt the ciphertext to the plain text. So this is what happens in the public key encryption process. So this is like sender encrypts, secure transmission, and receiver decrypts. So this is the process that takes over here in the public key encryption process. So what are the advantages if you see of both conventional, which is otherwise called as symmetric key encryption, and public key, which is otherwise called as asymmetric key encryption? So first we will see about the advantages and disadvantages of conventional, that is symmetric key encryption. Advantages are extremely fast encryption and decryption, requires minimal computational resources, perfect for bulk data encryption. Disadvantages are key distribution is a main problem here, doesn't scale well for multiple parties, and no built-in authentication. Similarly, if you see public key, that is asymmetric encryption, advantages are it solves this key distribution problem elegantly and enables digital signatures and authentication, scales excellently for many users. And then disadvantages are significantly slower than symmetric, requires more computational power, and larger key sizes are needed for public key encryption. So the best practice is modern systems combine both the approaches. Public key cryptography securely exchanges a symmetric key, which then encrypts the actual bulk data. So this hybrid approach leverages the strengths of each method. And what are the real world applications of conventional and public key cryptography? So first we will see about the private key cryptography or conventional. So here file and disk encryption, that is BitLocker, File Vault, and virtual private network tunnels for secure remote access, wireless network security, WPA2 and WPA3, and database encryption at rest, and public key cryptography, secure web browsing, email encryption, digital signatures for documents, cryptocurrency wallets and blockchain, code signing and software authentication. So this is a summary of conventional cryptography and public key cryptography, and as well as the combination of both is the hybrid approach. So first, conventional cryptography is chosen for speed, efficiency, and bulk data encryption in closed systems where secure key exchange is feasible. Public key cryptography is chosen for secure key exchange, authentication, and communication over open, untrusted networks. Hybrid approach, it combines both for optimal security, use asymmetric for key exchange and symmetric for data encryption. And now it's a question session for audience. So you can join at slido.com. So the first question is, what is plain text? What is plain text actually? Whether it is an unintelligible message or intelligible message. You can give the ratings. And next I'm going to give a quiz for you. And the first question is, what do you mean by AES? So whether it is applied encryption standard or advanced encryption standard or algorithmic encryption scheme or advanced encoding system, you have to choose the best. So what do you mean by DES? So the data encoding scheme, digital encryption standard, data encryption standard, digital encoding system. So what will be the answer? Guess and answer choose the best answer. Thank you, dear students. And we will see the next topics in the upcoming sessions. Thank you all.